Hello everyone, welcome to a video on properties of numbers. The goal of this video is going to be to learn about properties of equality, properties of addition and multiplication, and the commutative, associative, and the distributive property. But let's start with a few definitions. We're going to learn about equivalent expressions. An equivalent expression is an algebraic expression that are equal in value. They represent the same number. For example, if someone gives you 3x plus 7y and someone else gives you 7y plus 3x, they're talking about the same expression. They are equivalent. Similarly, if you have 4k plus 8k and you combine the like terms into a 12k, both expressions, the left and the right, are equivalent. They're equal to each other. So the properties of numbers, which we will cover in this lesson, is going to allow us to create equivalent expressions for any given expression. Now, some of these properties are going to seem kind of silly, but they are what will allow us to modify and solve equations. So let's get started with the properties of equality. The reflexive property states that any quantity is equal to itself. If we think of it in symbols, that means that for any number A is equal to A. But let's do a more realistic example. It just means that if we have a 5, well, 5 is going to equal to 5. The symmetric property states that if one quantity equals a second quantity, then that second quantity equals the first. Let's do it with symbols. So for any number A and B, if A is equal to B, then B is equal to A. Using an example with numbers, it just means that if 15 is equal to 5 plus 10, then 5 plus 10 is going to equal to 15. Notice that this property is going to allow us to switch the equations. Now, the transitive property states that if one quantity equals a second and the second equals a third, then the first one is also going to equal the third quantity. Using symbols, that means that for any numbers A, B, and C, if A equals to B and B equals to C, then A equals to C. Let's do it with numbers now. So if 5 plus 8 equals 2 plus 11, and 2 plus 11 equals 13, that just means that 5 plus 8 also equals 13. I said it, they sound kind of silly, but they are going to be incredibly helpful later on. And finally, for the properties of equality, we have the substitution property, which we have actually used before if you saw the previous video. A quantity may be substituted for its equal in any expression. So that means that if A is equal to B, then I can replace A in any equation or expression for B. Using numbers, which we've done in the past, it says that if n is equal to 11 and I have an expression 5n, then I can replace n with 11. Let's try some different properties. Now we're going to do the addition and multiplication properties. The additive identity property states that for any number A, the sum of A and 0 is going to be A. In symbols, it means that A plus 0 is going to be A, but also 0 plus A is going to be A. And we know this is true if we use numbers. If I add 5 plus 0, that's going to be 5, and 0 plus 5 is going to be 5. The additive inverse, a number and its opposite are additive inverse of each other. So if I add A plus negative A, then that is going to be equal to 0. So if we add 5 plus negative 5, that's going to be 0, because adding a negative is the same thing as subtracting, and we know that 5 minus 5 is 0. Let's do now the multiplicative identity. It states that for any number A, the product of A and 1 is A. And we know that product means multiplication. So in symbols, that means that multiplying A times 1 is going to equal to A, or 1 times A is going to equal to A. This one is extremely important. That means that if I ever have a 1A, I can just write A. Or if I have A, then I can write 1A. Using numbers, I know, I keep using the 5. I don't know why. So 5 times 1 is equal to 5, and 1 times 5 is equal to 5. Two more for the set. The multiplicative property of 0. So for every number A, the product of A and 0 is 0. That means if I multiply A times 0, or 0 times A, that's going to be 0. Now be careful here with this one not to get confused with the additive identity. This one states that if I multiply times 0, I get 0. And the additive identity says that if I add 0, I get back what was being added. So be careful not to confuse the additive identity with the multiplicative property of 0. Let's do an example with numbers. So 5 times 0 will be 0, or 0 times 5 will be 0. The last one for the set is the multiplicative inverse. It states that for every number A over B, now be careful, it doesn't have to be a fraction, it can also be a whole number. So for every number A over B, where A or B are not 0, there is exactly one number, B over A. Notice that's the reciprocal or the inverse, such that if we take the product or multiply them, the result is 1. So right here, if I multiply A over B times B over A, that will be 1. Similarly, if I switch these, B over A times A over B is also 1. Let's do an example with numbers to better see what this one is telling us. So if I multiply 4 over 5 times 5 over 4, like this, the result is going to be 1 because, remember, we multiply fractions across. 4 times 5 is 20, 5 times 4 is 20, and 20 divided by 20, that's going to give us 1. Similarly, if we do 5 over 4 times 4 over 5, that is also going to be 1 because these are reciprocals. Checking the numbers, 5 times 4 is equal to 20, 4 times 5 is equal to 20, and 20 divided by 20 is equal to 1. Now you might be asking, how exactly will that apply to a whole number? Good question. Let me get a pen. Let's say that I have the number, well, let's stay with 5. If I have 5, the reciprocal of 5 is 1 over 5. So that means that this is equal to 1. Why is that? Well, 5 can be written as a fraction 5 over 1. And if I multiply times 1 over 5, multiplying across, this will be 5 divided by 5, and that equals to 1. You can think of these two as being eliminated, and all we have left over is the numerator. Let's move on to the last set. We're going to talk about the commutative and associative property, and then we'll do the distributive property on its own. So the commutative property states that the order in which we add or multiply numbers does not change the sum or product. Notice how it doesn't say anything about subtraction or division. This property is for addition and multiplication. In symbols, for any number A and B, A plus B is equal to B plus A, and A times B is equal to B times A. Using numbers, 5 plus 6 is the same as 6 plus 5, and 5 times 6 is the same as 6 times 5. And we also used this property in the previous video for this lesson. And now the associative property. It states that the way that you group numbers when you are, once again be careful, when you are adding or multiplying, it does not change the sum or product. So for any numbers A, B, and C, if I add A plus B and then add C, is the same thing as adding B plus C first and then A. With a product, A times B and then multiplying C is the same as multiplying B times C and then multiplying it times A. Using numbers, if I add 2 plus 5 and then add 8 is the same as adding 5 plus 8 and then 2. Or if I multiply 2 times 5 and the result times 8 is the same as multiplying 5 times 8 and then multiplying the result times 2. All right, the last property that we are going to go over is the king of properties, the distributive property. The distributive property states that multiplying the sum or difference of two or more numbers is the same as multiplying the numbers separately. Let's see if we can clarify that using symbols. It says that if you have the numbers A, B, and C, and you have 8 times the sum, is the same as adding their products separately. What that means is that this value outside the parentheses is going to distribute and multiply B and C. So the product distributes over the sum. Similarly, if this had been a minus, I can still multiply the A times B and then subtract A times C. The same thing happens if that value is at the end of the expression instead of the beginning. I can distribute this A to multiply B and C, and we get 8 times B plus A times C. And the same thing will happen with subtractions. So 8 times B minus 8 times C. Let's do some examples so that we can better understand this property. Example 12 is asking us to simplify using the distributive property. So we have this minus 7 outside this parentheses. So that means that this minus 7 is going to multiply 3x, and this negative 7 is going to multiply this 2. So we will have negative 7 times 3x, and then negative 7 times this minus 2. When we multiply something like this, we are going to multiply the numbers, okay? These numbers get multiplied, so negative 7 times 3 will be 21, and we bring the variable, and then negative 7 times negative 2, be careful, the negative will turn into a positive. So our result will be that negative 7 times 3x minus 2 is going to equal to 21x plus 14. All right, this B is a little different, okay? But I think that you can do this one. Let's pause the video, give it a go to this example 12B, and then come back and see if you get the same answer. All right. So notice in B, we have an extra term that is not part of this multiplication. So I'm going to bring that one down. And then I'm going to concentrate on the distributive property. We're going to multiply 2 times 5 and 2 times 7p. So that means this positive 2 times 5 and the positive 2 times 7p. Working from left to right, we have some multiplications and addition, but each of these is a different term, so I can just bring this one down, concentrate on the multiplication, so 2 times 5 will be 10, and on this multiplication, remember we multiply 2 times 7, that will be positive 14, and bring down the variable. Now if you got this far when you pause the video, that is excellent work. The only difference between 12B and A is that now I have a pair of like terms. So the way that we are going to write this result is by writing the variable first. This is 14p, and then we add the like terms, and that will be 11. So then 1 plus 2 times 5 plus 7p is equal to 14p plus 11. Almost painless. Let's try a couple more, just to make sure that we fully understand the distributive property. Let's do B together, and then you can pause and try A and then come back to see if you get the same result. Now you're going to notice that this one has two parentheses. The first parenthesis has a 7 in front that will have to be distributed, but this one doesn't actually have a number. So when that happens, remember the multiplicative identity property that we talked about before? That one is going to come in handy right now. So we can do the following. I can keep the first one as is, but right here, without actually affecting the expression, I can multiply by a 1. So we can put a 1 to help us. Now, do we have to put a 1? No. I'm just going to put it there to help me do the distributive property, but if you can already see it, then you don't have to worry about that. So for the first parentheses, the 7 will be distributed over the 2x into this minus 3y. And for the second parentheses, we're going to distribute a negative 1 times x and a negative 1 times 5y. So 7 times 2 will be 14. Bring the x. 7 times negative 3 will be negative 21. Bring the y. Negative 1 times x will be negative 1x. Why is that? Because I can put another 1 right there. And negative 1 times 1 is negative 1. And now negative 1 times 5y will be negative 5y. Okay, going from left to right, let's concentrate on like terms. I have the 14x minus 1x, and that's going to be 13x. Continuing on, I have two more pairs of like terms, and that's going to be the minus 21y and the minus 5y. Since they have the same sign, we're going to add them. So negative 21 minus 5 will be negative 26. And don't forget to bring the variable. And this will be our result. Let's see. Pause the video, try 13a, and then come back and see if you get the same thing. All right. So for this one, we only have one parenthesis. So we're going to distribute the 2 to the x and to the negative 3. Now this 2 is not going to distribute to these other two terms because these two terms are not inside the parentheses. When you are multiplying 2 times x, remember you can put a 1 to help you do the multiplication. So 2 times x will be 2x, and 2 times negative 3 will be negative 6. And since these are not inside the parentheses, they don't get multiplied, so all we do is bring them down. Let's take care of like terms. Going in alphabetical order, 2x minus 7x. Different signs, we subtract, keep the sign of the largest. So 2 minus 7 is negative 5. Don't forget to bring the x. But we still have another pair of like terms, and that's minus 6 plus 4. Again, different signs, we subtract, keep the sign of the largest. So negative 6 plus 4 will result in a minus 2. All right, this is the last example for this video. Now is your turn to see if we understood everything that was covered in this video. Thank you so much for watching, and I'll see you in the next one.